In this video, I'll show you how to draw an equilateral triangle from a circle using only a ruler and a compass, and how subdividing the circle can lead to fascinating geometric figures. You'll be surprised by how much can be achieved with these simple geometric techniques. I invite you to see first a brief historical overview of how this figure has been used throughout time and across cultures. Since ancient times, the circle has been a universal symbol of unity, perfection, and eternity. But when we divide it into three equal parts, or multiples of three, this simple geometric operation becomes the foundation of some of the most beautiful and meaningful designs in history. In the Celtic world, for example, we find the triskele, a motif formed by three interlaced spirals within a circle. This symbol represented movement, energy, and balance, and remains one of the oldest emblems of sacred geometry to this day. In Japan, we find the mitsudomoe, three curved shapes rotating within a perfect circle. It is a symbol often seen in Shinto temples dedicated to Hachiman and in Japanese heraldry, associated with strength, protection, and harmony. During the Middle Ages, dividing the circle into multiples of three became a fundamental tool for cathedral builders. The great Gothic rose windows, such as those of Notre Dame in Paris, are structured upon 12 or more lobes, all derived from circular divisions based on equilateral triangles and hexagons. The result is a symphony of light and color that continues to astonish us even today. In the Islamic world, the artisans of the Alhambra in Granada perfected this technique in intricate mosaics. Their 12 and 16-pointed stars, always inscribed within circles, show how mathematics and art can unite to create timeless beauty. This geometry also appears in Buddhism. The Dharma chakra, or wheel of the law, is often represented with 12 or 24 spokes, all multiples of three. This symbol recalls the teachings of the Buddha and the infinite cycle of existence. In the pre-Columbian world, both in the Andes and Mesoamerica, geometry was more than an aesthetic resource. It was a practical tool and a symbolic language. Andean cultures such as the Incas or the Nazcas developed textile and ceramic designs filled with perfectly regular, often equilateral triangles, arranged in repeating bands and friezes. In Mesoamerica, the Maya and Mexica expressed geometry in their codices and temple architecture. Triangular patterns combined on walls, stairways, and friezes. Even the solar calendar itself is structured through divisions related to multiples of three, such as the 18 months of the ritual year. Thus, from the Nazca lines to Mayan murals, dividing the circle into three, and the presence of the equilateral triangle became a bridge between the observation of the natural world and artistic creation. And if we look around today, we'll see that this same idea appears constantly in our daily lives, in modern graphic design, logos, infographics, and digital visualizations, where dividing a circle into three remains a clear and elegant way to express information and balance. Across cultures and eras, this geometric construction has served as a bridge between mathematics and art. That's why, in this tutorial, we'll learn step by step how to divide a circle into three parts and its multiples using simple techniques, with ruler and compass, because geometry is not only a tool, it is also a form of beauty. Let's begin. Drawing an equilateral triangle using only a ruler and compass is quite simple. All we need is to draw a circle and divide it into three equal parts. Mark with a dot or a small cross what will be the center and draw a circle with the compass. Then, keeping the same compass width, place the needle anywhere on the circumference and draw an arc to one side. In this case, I did it to the left and then another one on the opposite side. You'll notice that along the way, the pencil of the compass passes exactly over the center of the circle. Now use the compass to measure the distance between the two marks, and with that opening, place the needle on one of the marks along the circumference and make another mark above, as shown here. Then, although it's not strictly necessary, position the compass on the opposite side and make another mark above the circle to ensure the placement is correct. With these 3 points marked on the circumference, we can now draw our equilateral triangle. So far so good, except for one small detail. Orientation. If we want the base or one of the sides of the triangle to be perfectly horizontal relative to our drawing surface, we'll need to add one more geometric element, so we don't have to guess the compass placement by eye. The solution is simple, as we'll see next. Start by drawing a vertical line perpendicular to the bottom edge of your drawing surface. Define the location of the center and draw the circle at the desired size. Then mark the two lower points on the circumference as we did earlier. Keeping the same compass width, place the needle at the intersection of the vertical line and the circumference. Make one mark to the left and another to the right. With the vertical line, we already have the third point that gives us the top vertex of the triangle. But if we want to make sure everything is correct, let's measure the distance between the lower marks with a compass and, using the same width, draw the corresponding marks above. If it matches the previously marked intersection, we can draw the sides of the triangle, confident that all three will be the same length. We've drawn an equilateral triangle. Now let's go back a few steps, before drawing the triangle. What do we have? We get a circle divided into 3 equal parts by the marks made with the compass. We also have a line that, starting from the top mark, passes through the center of the circle and divides the lower arc into 2 equal parts. By drawing the other 2 lines that pass through the center and intersect the lateral marks of the circumference, we obtain this shape. The circle divided into 6 equal parts, which allows us to draw 2 equilateral triangles in opposite directions, as seen here. One triangle points upward and the other downward. And what do we get from this? When you superimpose 2 inverted equilateral triangles, you get a 6-pointed star called a hexagram. In Hebrew tradition, this hexagram represents the Star of David. In India, the Satkona hexagram is interpreted as the union of the masculine, the triangle pointing upward, Shiva, and the feminine, the triangle pointing downward, Shakti. We also obtain a 6-pointed star formed by 6 smaller equilateral triangles surrounding another geometric figure, a 6-sided polygon called a hexagon. In Islamic art, the hexagon and triangle are used in mosaics and geometric patterns as the basis for complex tessellations. If we connect all the intersections or outer points, we obtain another hexagon. Notice that its position is different from the inner one. Let's go back again to a previous stage and first connect only the outer arcs. Then draw 3 concentric lines, using the auxiliary lines as guides, just as shown in the images. What we'll obtain is a cube in what we know as an isometric projection.
If you enjoyed this video or found it helpful, don't forget to give it a like. Got questions or want me to explain something in more detail? Just drop a comment below. And be sure to subscribe so you don't miss upcoming tutorials. It also really helps me keep making more content. Thanks for watching. See you in the next tutorial.